Wind power is a proven technology that is being refined and updated to make it more efficient and economically viable. But some scientists have their research sights set on the Earth's ultimate energy source, the sun. But they don't plan to harness its power, they want to imitate it. The diameter of the sun is about 100 times that of the Earth. It's a giant ball of pure energy. The sun produces enough energy every second to power our planet for 1 million years. The sun's energy is generated by nuclear fusion. But we don't need to travel 180 million kilometers to harness fusion power. It can be generated here on Earth.
Fusion is important because it's something that's going to give us a really, really long-term sustainable energy source.
The scientists at the Joint European Torus nuclear fusion research facility near Oxford are investigating fusion for its potential to provide an unlimited supply of cheap, clean energy.
We are taking the power source of the sun, which is something very ambitious, but I think it's something very worthwhile attempting to do.
In 1945, the world discovered the power of splitting the atom. Today, all nuclear power plants split atoms in nuclear fission reactors. The main drawbacks are a lack of good options for the disposal of spent fuel and the danger of an accident that releases radioactive material into the air or groundwater. But a fusion power plant would produce no deadly radioactive waste. It can't melt down and uses a clean and abundant source of fuel. Inside the torus experiment, atoms aren't split apart. They're fused together. It's a process that uses no radioactive plutonium or uranium. The fuel is hydrogen. Hydrogen atoms are heated to 150 million degrees centigrade, 10 times hotter than the sun's core. At this extreme temperature, the atoms turn into a plasma. The plasma atoms collide and fuse. Energy is released when the positively charged plasma ions overcome their natural repulsive forces. It's 1 million times more efficient than today's nuclear power stations, and 1 trillion times more efficient than fossil fuel. This clean energy confines the high-temperature plasma with magnetic fields. The technology is inherently safe, but the experimental machine is expensive. So more than 160 safety checks take place before the countdown to ensure there will be no damage to the machine.
Everything we do, we need to be totally sure we've got everything right. We can't afford any mistakes, and it can be a little bit tense at times.
The machine is housed behind 2 meters of concrete and steel.
Trigger the pulse, please.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
A camera monitors the experiment. The glowing light is plasma, superheated gas, which can reach 200 million degrees. The reaction produces energy like any star in the solar system. Nuclear fusion here on Earth.
We did good.
That was excellent. That worked exactly as we wanted it.
It's perfect.
I'm happy. I think the scientific coordinators are very happy. You can see lots of smiles, in fact, so, which is good.
Nowhere in the world have scientists come closer to creating the ultimate energy source. And the fuel for fusion is virtually unlimited.
One bathful of water would provide enough energy through fusion to supply one person with all their energy needs. So their transport, their heating, their food, their industrial needs for 30 years.
Because fusion is fueled by hydrogen, there are few security risks. But research is still at the experimental stage. Scientists estimate it will be another 30 years before there will be a commercial fusion power plant.
This is a very long-term strategy. This isn't something that's suddenly going to produce a result tomorrow and solve all our problems. So we will get there. I don't think we have any choice.
Maybe the visionary scientists and entrepreneurs who are developing renewable, clean energy solutions will be able to offer us viable choices. The planet's increasing population and expanding energy demands may well depend on them.